Hello. Testing. Okay, in this video we're gonna look at how we're gonna generate a Bezier curve. Okay, task number 1, generate a Bezier curve of degree 2 with 3 control points. So degree 2 means 0, 0, 1, 2. So the highest power in this equation is 2. That's the meaning of degree 2. So for Bezier curve, if it's degree 2, it means that it has 3 control points. Okay, so we need to generate a Bezier curve with 3 control points, and then we can come up with our own control points. Okay, so let's say we have 3 control points, P0, P1 and P2. So instead of I just put X, Y and Z, so X, the coordinate of P0, P1 and P2 for X and Y. So let's say X, that's for the first P0, 1 and 0. Okay, and then this I put 0, 1, 0. Sorry, this one I put 2. Okay, and then let's try to plot this one. Plot X, Y, just so that we can see how it's look. I put the color in blue. Oh, sorry, not this one. And then this one I put it's in something like this, in such a way if we plot this one, it will be something like let's run. Okay, so that's this the 3 points. So before this, in Bezier curve, we know that the shape of the curve should be something like a parabola, like this. So these are the equation of Bezier curve. So what we'll do is that we're gonna create that thing. So before that, we need to define t. So t is from 0 with the increment of 0.1 until 1. You know what, we for this example, we will increase the increment to what, to make the curve look smooth. Okay, and then px for control point x, so px is equals to x1, meaning that it's the first point, times 1 minus t, and then square, plus x2, meaning that this is p1, times 2 times t times 1 minus t, this is just from the equation, plus p2 is x3 times t square, t dot to the power of 2. Okay, that's for px, and then we need to do the same thing for py. So just copy paste and then change x into y for this one. And then we plot that thing back. Plot px comma py, and then let's say I want it in black. So I put b. So no, sorry, b is blue. So k is black. K is black. So let's plot. Before that, I need to put hold on to hold the previous figure, and if I run, okay, there's something wrong. Okay, I need to put dot here. So this is multiply element. Run. Okay, so you see the curve. Okay, let's say I change this one. So now look, before I change, it's something like this, and after I change, if I run, Okay, maybe I need to put CLF. CLF stand for clear figure. In such a way, it will remove or it will clear the previous figure. So I run again. You see, not smooth like 0.01. So this one I change 0.01, and now I change. It will become more smoother, smoother. Okay, that's the one. And then let's say if we change the location of control points. If let's say this point, I want to change it somewhere down below. So this one, the coordinate of y is 1. So I want to change to -1. And then let's see what happened. Okay, the curve will look like that. And let's say I want to change the location of this one somewhere here, which is x equals to 1. X equals to 1. That is the third point. Instead of this one, I want to change. Okay, you see, so it follow the characteristic of Bezier curve. You can understand that by looking at the previous video. Okay, now we do task 2. So generate a Bezier curve of degree 3, which is 4 control point, and then we can come up with our own control point. So what we'll do is that we'll just copy paste this thing. We'll put here because we just change a bit of this thing. So instead of having 3 control points, so I increase another control point. I can give any value for now. Okay, and then this will be the same thing, this will be the same thing, this will be the same thing. The only thing that we need to change is here, and then we will use this is the one that we get from the calculation before. So instead of 1 to the power of 2, that to the power of 3, so we need to change for both to the power of 3. And x2, this one 3t, right? So this one I need to change to 3, this one I need to change to 3. 3t 1 minus t to the power of 2. So this one I need to add to the power of 2. Okay, and then this one for x3, t square, that one is correct, but then I need to multiply with 1 minus t. That is inside here. And don't forget to change, to add one more, to add times 3, this one, p2 times 3t square, so x3, the control point, times 3 times t square, okay, and then times 1 minus t, so 1 minus t, and then copy pasting the whole thing, and then I put it here. Okay, and finally p3t cube, which is what okay, the next control point is x4 times t to the power of 3. So that's for x, and it will do the same thing for y. Okay, I believe that's it. And if we plot this one, just run the section. So 1 2 3 4 control points. Okay, and I can change. Let's see what happened. Let's say I change this control point and I want to put it here, and the coordinate is 2 0 2 0 2 and x, y 0, and then let's run this section. Boop. Okay, it will be something like that. 2 0 2 2 0. Okay, oh, I put 2 negative ones. I just wanna, we can change. Okay, so it will give you that kind of curve. Okay, so that's how you do task number 2. Okay, we have done 3 control point degree 2. We have done 4 control point degree 3. So what if we, let's say we want to we use this this equation instead of we want to create a Bezier curve of degree n, meaning that we change number of control point, automatically it will create the curve. Okay, so we will make use this Bezier curve. Okay, so these are the equation of the Bezier curve, and then to do that we we need to have this and this. Need to have the control points and this one, and then also we need to define all of these things. Okay, for that, so let's define. Let's use this one. So we will just gonna use this one first. Okay, let's say you have this control point. Okay, for now we use 4 control points, but in the end, after this, what we will do is that we will change the number of control point, and automatically it will create the curve. Okay, so but for now let's assume we have only 4 control points. Okay, so if I plot this, so this is the control points, the location of control points. Okay, okay, now we want to do this. Okay, for this we need to have loops, because if you see here, this is summation, so meaning that this plus another one plus another one, right? So which is why we need to have this what we call loop. But before that, just to find this. Okay, let's say we want to find this, right? bint is equals to n choose I, ti 1 minus t n minus I. Okay, and n minus I is n factorial over I factorial minus I factorial. So fortunately in MATLAB, there's a function n choose k, where let's say if let's say I write n ci, this is just a variable's name, n choose k, and if I do, let's say 2 comma 0, this is just try, right? Just try, and if I run this, it will give us 1. What does it mean? 2 choose I, this one, 2 factorial over I is 1 factorial, 0 factorial, which is 1, and then 2 minus 0 factorial, so 2 factorial over 2 factorial, so it will give you 1. So let's try another thing, 2 1. So that one is correct lah. Should I say kan? That one is correct. So I run this one, 2. So 2 factorial over 1 factorial over here, 1 factorial, it will give us 2. So instead of writing this one n factorial over I factorial, we will just use this one, which is a built-in function in MATLAB. So we'll just use n this one. Okay, if let's say n equals to, this is I'm just assuming, so now you have this x and y. So if x, y, so 1 2 3 4, right? So 4 control point. So what is n? N is number of control point minus 1, right? Before this, okay, 4 control point, n equals to 3, then the degree equals to 3. So if you have 4 control point, n equals to 3. So one way to find n automatically is by having this. So in MATLAB, there's a built-in function, length. So we want to find the length of x, but then the length of x is 1 2 3 4, 4. So 4 is not equals to n. So you need to minus 1. So n equals to length of that data point, number of control point, minus 1. So instead of having 2 here, so I can put just n. So it will calculate this thing automatically. So I hope we can agree on that lah. Okay, so and then we need to have this I, and remember I here start from 0. So because of that, so I just create this one, for I equals to 0 until n. Okay, equals to 0 until n. Okay, I just do this one first. So n choose I, n choose I. So if I run this, okay, so for control point, remember binomial, 1 3 3 1. So I believe that one is correct. So the NCI, now it's correct, so I can put that sign over there. And then, okay, we have finished this n choose I, and then t to the power of I 1 minus t to the power of n minus I. So b is equals to n choose I, okay, times t to the power of I, so t to the power of I, but don't forget this dot, and then this dot times 1 minus t to the power of n minus I. Okay, so I think that one is correct. Okay, we have done that. And then the control point, if you look at this equation, the control point multiply with the basis function. Okay, so for this, the x multiply with basis function. So that is for x lah. That is for x data. So x data, x of instead of I, so we need to plus 1 because I starting from 0, but in MATLAB the index start with 1. So this I is for n choose I and so on for this one, but then because of this control point, the indexing in MATLAB starting with 1, so I need to put xi plus 1, xi plus 1 times b, the basis function. Okay, so that is that. Okay. Okay, so it's look correct now, but remember this is a summation. This is summation, which is why we need to we call this one as pre-allocate. Px equals to zeros. This is not a must, but this is a warning. Like if you didn't do this, it will give warning in MATLAB. So px equals to zeros with size of t. So this one, and then I'll create another variable's name py, py0, which is the same thing, and then this one px equals to the previous px plus x I plus 1 times b, and we will do the same thing for py. So you check this one, you check why I do like this. This in such a way this will agree, this will agree with this equation, because summation, this one plus the previous one plus the, so in such a way we will get all of px and py. Okay, and finally we will plot the curve. We'll plot the curve. Okay. Okay, so maybe correct, maybe wrong. We run first, then we will know. I think this one is wrong. Why this is wrong? Xi plus 1, you know what, sometimes we will not know whether this one is correct. Px, the same px, py, the same py, then we run again. You know, I think this one is wrong. We should get the curve. So there must be some miscalculation somewhere. What I just want to remove this one in such a way we can see what happened to the equation. 1331, that one is correct. The basis function, it's look correct, but it's not. The px py equals zeros to the size of t, it's look correct. Okay, because this one is y, so I should change this one into y, and then if I run again, it will recovers the same curve. So I want to remove this one. I run again, Okay, it will give you this curve. Okay, if let's say I want to increase the number of control point, I put 1, I put 0, I run again, so it will automatically create the curve. And then I put this one 5, and I put this one 1, it will create the curve. It will create the curve. Okay, this is for design. Okay, okay. Okay, so we have done this task number 3. Next, we move on to task number 5. Design a heart-shaped Bezier curve based on 9 control points. So instead of having a long equation, so why not we just use this one? We'll just use this equation. This code over here. So just put here. So what we'll need to do is that we need to have these 9 control points over here. So this is just a draft. Actually, you can come up with your own control point in such a way it will look like a heart shape. I start from here. This is the first control point, second, third, fourth, fifth, sixth, seventh, eighth, ninth. Okay, so start with this here. So here the coordinate is 0, 0, so 0, 0. The second one is -2, 1. So x is -2, y is 1. Okay, the third one is x is -2, y is 5. So -2 and then 5. Okay, and then here -1 and 5, -1 and 5. Okay, and then over there, down there, 0, -2, 0, -2, and then move up here, 1, 5, so 1, 5, okay, and then here 2, 5, 2, 5, and then we go down here, 2, 1, 2, 1, and then the last point here, 0, 0. We goes back at the first point, 0, 0. Maybe correct, maybe correct, maybe wrong. Okay, so it will give us the same shape. So you can change the coordinate of this in such a way you can create the heart shape that you like. Okay, so you can increase the number of control point, decrease, but the instruction asks you to write how many 9 control points, so you need to fulfill the needs. 9 control points. Okay, that's it. Okay, now write a Bezier curve. Task number 5, write a Bezier curve of degree 2, n equals to 2 in matrix form. So these are the one that we get on the slides before. So degree 2. So degree 2, so I will just use this one first. I just want to copy paste this thing first. Okay, so degree 2, so 3 control point, so I will just use this control point. Okay, and then okay, so instead of using this, so I just want to put comment here. Okay, and then so what we will do is that to find to create this one. Okay, so this one is a matrix T, so I name the matrix T equals to T squared, T to the power of 2. Maybe I put some dot over there, and then I put this one T, and then I put this one and once, because need to fulfill the what the matrix size. Okay, one with the size of T. Okay, and then I just want to remove this one. I just want to put a comment first. if I run this one, so it will give us 3 times 101. So I want to know the size of the matrix. In such a way, after this we will do matrix multiplication. So the matrix multiplication must agree with the rules of matrix. So which is why I put that. I want to know the size, which I put there. Okay, T. And then I have this matrix. So I want to name this matrix as I write B2 lah, because Bezier matrix with n equals 2. So I just want to put 2 there. And then that is equals to, so this one I will remove first, don't worry. Later on we will put that back. So 1, -2, 1. And then next row, -2, 2, 0. And then next row, 1, 0, 0. Okay, so we have that. And then finally, the control point. So I want to remove this one also. Okay, and if I run, okay, now we know. Okay, maybe I put this one. I put a command Control R for this, just in such a way. Okay, now we look. Look here. So this, the size is 1 times 3, 1 times 3. T is 3 times 101. And then B2 is 3 times 3. So to make use of matrix multiplication, so we need to follow the rules of matrix. So Px, T times B2, so matrix T times B2 times the control point. So T here, 3 times 101, and B2 is 3 times 3. So you cannot do multiplication T times B2 directly. So you need to, we need to do, we need to put T, we need to transpose. So to transpose, just put this, to transpose, apostrophe, and then times B2, okay, I believe that one is correct, and then times, okay, times 1 times 3. So this also is wrong. So the metric is 1 times 3. So you need to put X transpose. So it will be 3 times 1. 3 times 1. Okay. And then you put this sign. Okay. And then, comma, this one, Px, and then for Py. And then I change this one for Y data. So this one I can remove directly. I do not need to have this one. I do not need to have this one. And then this one, Control T to remove the comment. And then I put this one, Control T. Okay. Is this correct? So we run first. Okay. It will give us the same curve, the same curve. And then just to remove this thing in such a way it will not pop out here. So I put this one, put this one, I put this one, I put this one, and then if we run again, it will give us this curve. Okay, and then finally use the Casteljau algorithm to generate a Bezier curve of degree 2. Okay, so for this, you need to separate instead of having this thing. You still have that thing, but you need to separate P0, P1, and P2 lah. Because in such we will. You know what? If you don't want to separate, also I believe it's okay. You still can get the data lah, but you need to separate X and Y. That's one way lah. If you wish to do that, but if there's multiple way lah, this is not the only way, but what I'll show you this one. I'll show you this one. So what I will do here is a bit different lah, but it's actually the same thing. So P0 equals to so let's say these are the control point, right? The first control point. So I put 0, 0, and then the control point number P1, number 2 is 1, -1. So I just want to follow this one, 1, -1, 1, 0. So 1, -1, and then P2 equals to 1, 0. So 1, 0. Okay, and then that's it. And then this one, So I wanna this one because I want to plot the control polygon. P01, P11, P21. So this one P11, P21. These are indexing. I hope you already understand this. So I'm doing this one a bit fast. So you just pause the video, or you can rewind the video in such a way. Hopefully you can understand. Okay, and then I can plot that thing. Plot the control polygon. Okay. Okay. Let's try and run first. Okay, the same control point actually, the same control point, control polygon. Okay, now di Casteljau ke now we will do di Casteljau ke so we need to define t. Okay, t as usual 0 with the increment of 0.01 until 1, which is correct. Okay, and then p01, so yeah, p01 is equals to 1 minus t times p naught plus t times p1. Okay, so we do that one first. We run this one first. Is this okay or not? Okay, something wrong with this. So what we need to do? So why that's wrong? Because because of the size of the matrix lah. Because matrix multiplication punya rules of matrix multiplication. So all we need to do, we just need to put dot here and dot here, and if we run again, so it will give us something. So that one assumingly correct. Okay, that is p01, and then we need to do the same thing for p12. Okay, this one is p12, so the connection between p1 and p2. Okay, and then we copy paste p012, but this one with the connection of this p01 and then p12. Okay, let's run first. Ada error tak? Okay, no error. Okay, now we want to plot. Okay, to plot if we run, wait. Okay, we know that the size of p012 is 2 times 101. Okay, so for plot, you cannot use the normal, the original px pyk. You cannot use that. Instead, you need to plot p012, 2 times 101, right? So the first row, this is for x data, first row for each column. Okay, and then this means that the x lah. This is for px. This is the meaning of px. And for this, for y, p2. Row number 2. So we plot again. Okay, so it will give us the same curve. Okay, so good luck. So please try and do this. Okay, thank you. Bye. Assalamualaikum and good day.